Assalamualaikum and a very good day. So today we are going to proceed on the binomial probability. So this binomial probability table, we usually use for the trials more than 10. So what is trials? Okay, the trial is the n. Okay, so we have the binomial distribution, okay, in which we have the n number of trials and we have the p probability of success. So for this binomial probability table, okay, we can get the probability when you have x greater and equal to k. So if you find this probability, you can get the answer straight from the table. For example, when we are looking for the probability x greater and equal to 2, so we can get the answer straight from the table. Okay, so now we look at the binomial probability table. Okay, this table 1 is the binomial probability table. Okay, again we have the P and also we have the N. Let's say we have a binomial distribution. Okay, we have the N and we have the P. For example, we have the N is equal to 5 and we have the P is equal to 0.3. So we have binomial 5 and 0.3. Okay, now, so let's say the question asks to find the probability when you x greater equal to t. Okay, now, from this example, we have the value of n, which is equal to 5. We have the probability P, which is 0.3. And we must find the value of the probability when your x greater or equal to 3. Now, we have the x greater and equal to 3. Okay, so that means we can get the answer straight from the table. Okay, so if you look at this table, this P, okay, we have 0.01, 0.02 up to 0.09 and we have the value of n 2 and 5 up to n equal to 100. Okay, now we want to look for n equal to 5. So this is your n equal to 5. Okay, and your P is equal to 0.3. Okay, now when we look at here, we don't have 0.3, right? But for here, we have 0.1, 0.15, 0.2, 0.25 and 0.3. So that means we have the n equal to 5 and your P is equal to 0.3. So what is the value of your x? So your value of x is equal to 3. So this R, okay, is equal to your x. So your x is equal to 3. So now what is the value when your n equal to 5? Your P is equal to 0.3 and your R is equal to 3 or your x is equal to 3. So the answer is here. 0.1631. So this is how you get your probability from the binomial table. Okay, now we look at the second example. Okay, let's say we have our x, okay, approximate the binomial and our n is equal to 5 and our p is equal to 0.5. Okay, so that means this is your n and this is your p. Okay, so let's say the question asks you to find the probability when your x greater or equal to 5. Okay, so now when your x greater or equal to 5, that means you have the sign of greater and equal. Okay, so you can get the answer straight from the table. So again, we have our P is 0.5, so 0.5 is here, and our N is 5. Okay, this is our N is equal to 5, and the question asks you, okay, X greater equal to 5. So your X is equal to your R, so your R is equal to 5, so it's here. Okay, so what will be your answer? So you get your answer, the probability is equal to 0.0313. Okay, now what if the question asks you, okay, we use the same example, okay, we have the x approximate the binomial with n is equal to 5 and our p is equal to 0.5. Okay, let's see the question asks you to find the probability when your x less than and equal to 2. Okay, now we have the sign, the symbol of less than and equal to 2. So can you get the answer straightforward from the table? No, cannot. We just can get the answer straightforward from the table if we have the symbol of greater and equal to. Now the question is less than and equal to 2. So how to get the answer? Okay, to solve the problem when your x less than and equal to 2. Okay, it's here. Okay, we have the symbol of less than and equal to. Okay, it's come from here, less than and equal to, and we have the k, let's say is equal to 2. Okay, from this example, x less equal to 2, so it's equal to 1. Okay, our 1 minus 2 x, our k is 2. 2 plus with 1. So x greater equal to 3. Okay, so we have to use this formula, this theory. Okay, 1 minus probability x greater than 3. So can we get the value of probability x greater equal to 3? Yes. For this one, we can get straightforward from the table because we have the sign of greater and equal. So now we have to look for the x greater and equal to 3. Okay, now, so for this example, okay, we must look the probability of x greater equal to 3 because from the formula, x less equal to 2 is equal to 1 minus probability x greater equal to 3. So we can get the value of x greater equal to 3 from the binomial table. So our n is equal to 5, our p is 0.5, and our s is equal to 3. So this one is our s equal to 3. So our answer is 0.5. So is equal to 1 minus 0.5. So is equal to 0.5. Okay, now we look at the next example. For example, we want to look when your x greater than 3. Okay, now can we get the answers straight from the table? Cannot because we have the x greater than 3. So what is the formula when your x greater than equal to 3? So when your x greater than 3 is equal to probability x greater equal, our k is 3 plus 1. That means we are looking for probability x greater than 3. So it's equal to probability x greater than, our k is equal to 3. 3 plus 1 is greater to 4. Greater and equal to 4. So that means when your x greater than 3 is equal to x greater equal to 4. Now, for the x greater than equal to 4, we can straightforward get the answer from the table. So again, we have our n is equal to 5, p 0.4, and our n is 0.4. So the answer is 0 is here, 0.187. 5. So this is how you get your answer, or how you find the probability from the binomial table. In other words, we can say that we must use the theory 5 or this table to get the probability for the binomial distribution. To find the probability x greater and equal to k, that means we can get the answer from the table. But if we want to find the probability when your x other than the x greater than equal to k, okay, that means we have the less than, less and equal, greater, equal to, others. Okay, so we must use this table. So in this table, okay, I already make an example, okay, for you. Okay, so you can look at this formula and also the example that I already given. Thank you.